Hello and welcome back. This is Teresa Adams with the Community College of Denver, and today we're going to work on the sum and difference of cosines. So we're going to simplify expressions first by using the appropriate identities, and as I look at this, I'm looking for specific patterns. I have the cosine, cosine, and then I have sine, sine. So it looks like it wants to be the sum of cosine. So then, or difference of cosine. So then I look to see whether or not I have the cosine of 23, and then over here I have the sine of 23, because they have to be the same angle. It has to be alpha, beta, alpha, beta. Cosine alpha, cosine beta, sine alpha, sine beta. So then I look and I have the cosine of 67 and the sine of 67, which means it does fall into the pattern of the difference of cosine. So this becomes the cosine of 23 degrees minus 67 degrees, which equals the cosine of negative 44 degrees. But since cosine is even, this just becomes the cosine of 44 degrees. Now as we take a look at our next example here, we've got the cosine, cosine, sine, sine. Alright, so it falls into that pattern. So I have the cosine of 5, the sine of 5. I have the cosine of 6, the sine of 6. So this falls into the pattern of the sum of cosines. So this becomes the cosine of 5 plus 6, which is the cosine of 11. I'm going to let you guys do the next one. That's right, it's the sum of cosines, so it becomes the cosine of 4y. Now, what we can do after we've got more familiar with the sum and difference of cosines, we can now do some problem solving. So, our first problem wants us to find the exact value of the cosine of alpha plus beta if we're given the sine of alpha and the sine of beta. They tell me where alpha and beta are. Alpha is in quadrant 1, beta is in quadrant, alpha is in quadrant 2, and beta is in quadrant 1. So I know that the cosine of alpha plus beta equals the cosine alpha, cosine beta, minus the sine alpha, the sine beta. Oh, beta. Let me change that to beta. So that means that I need the sine and cosine of alpha. Well, I've got the sine of alpha, so I've got a replacement for that already. I also have the sine of beta, so I have a replacement for that already. I need the cosine alpha and cosine beta. The way in which I find these is I go and say, okay, I'm going to go back to the way that we define sine and cosine in terms of x, y, and r. So since I know that the sine of alpha is 3 over 5, that means y is 3, r is 5, and x for alpha must be the square root of 25, that's my r squared, minus 9, that's my y squared, which gives me 4. So the cosine of alpha is my y value, which is 4, over my my r value, which is 5. So now I've got the cosine of alpha replacement. Alright, so I'm just going to write that over here. The cosine of alpha equals 4/5. Now I'm going to do the same thing for beta. So define beta, the cosine of beta. Ooh, but remember, alpha is in quadrant 2, so this should be a negative 4/5. So don't forget where the angle is in each quadrant so that you know whether or not it's a positive or negative answer. So now let's do the same thing for beta. So for beta, I have the sine of beta is 5 over 13. So that means my y is 5, my r is 13, and my x is equal to the square root of 13, which is 169, the square of 13, which is 169, and the square of 5, which is 25. Again, this is r squared minus y squared. And so our x value will be 12. So that means the cosine of beta, and I'm in quadrant 1, so it's positive, is going to be my x value, which is 12, over my r value, which is 13. Okay, so let me get rid of this so I can make it a little tidier. So I know the cosine of alpha, cosine beta. Cosine of alpha is negative 4/5. The cosine of beta is 12/13 minus the sine of alpha is 3/5. That was given to us. The sine of beta is 5/13. That was given to us. And because they want the exact value, I will do negative 4 times 12, and then over the 5 times 13. So I get negative 48 over 65, and then I have minus 3 times the 5 is 15, 5 times the 13 also is 65, and so my answer is, when I get done, a negative 63 over 65. So, as I go on to my next example, again they give me sine of alpha and sine of beta. I have sine alpha, and I have sine beta. Ooh, let me highlight that, not cross it out. I have the sine of beta. So like before, I need to find the cosine alpha and the cosine beta. And that way, I have to find the cosine of alpha plus beta is equal to the cosine alpha, which I need to find, the cosine beta, which I need to find, minus the sine alpha, sine beta, which I have both of those values. So I'm going to let you guys do that, and I'll give you the answer. All right, so let's take a look at our last example. We have, on the last example, we have the cosine of alpha minus beta. The difference between this last example and the first two is that this time I have the cosine of alpha and I have the cosine of beta. So I need to find the sine alpha and the sine beta. And I'm going to let you guys do that, and once again I will give you the answer. All right, great. And we'll see you on our next video.